In this video, we're going to continue with the last two sections of chapter 3. So that's 3.6, which deals with specific heat. And then we'll look at the energy calculations in a heating and a cooling curve when we come to section 3.7, right? So what is specific heat? Water has a very high specific heat. That means it's slow to heat up and it's slow to cool down as well, okay? So because of this high specific heat of water, it keeps the temperature, surrounding temperature, kind of more moderate in both summer and winter, because it does take a long time to heat up water, and unlike metals, which heat up really fast, water takes a long time to heat up and then a long time to cool down as well. So specific heat is different for different substances. As I said, for water it's pretty high, and for metals it's low. And it's defined as that amount of heat that you need. So if I had just 1 gram of water and I wanted to change its temperature from, say, 21 to 22 by 1 degree centigrade, all right? The amount of heat I needed to change the water temperature for exactly 1 gram of water by 1 degree centigrade, all right? That's the specific heat, and that's 1 calorie for water, all right? So that's quite high, all right? So 1 calorie for 1 gram of water to change its temperature by 1 degree centigrade, okay? When you convert it into joules, 1 calorie is 4.184 joules. So in terms of joules, the specific heat is 4.184 joules per gram degree centigrade, right? So these are the units for specific heat, calorie per gram per degree centigrade. So how do you calculate heat lost or gained? All right, so you take the mass of a substance times the change in temperature, all right? So initially it was at a certain temperature, and finally after taking in heat, its temperature went to a higher temperature, and so that change between the initial and the final temperature times the specific heat, all right? So grams, mass is in grams, the temperature is in degrees centigrade, specific heat is in calorie per gram degree centigrade. So the grams and the degree centigrade cancel, and you'll get your answer in cals. So heat is measured in cals, or it's measured in joules, all right? So if you take the specific heat in joules per gram degree centigrade, then of course the answer comes out in joules. So this is the formula for heat lost or gained. Mass of the substance times the temperature change that it has undergone times its specific heat. All right, so this is a lengthy problem, a word problem. It says, during surgery, a patient has suffered a cardiac arrest or stroke. Lowering the body temperature will reduce the amount of oxygen needed by the body. So some methods used to lower body temperature include cooled saline solution, cool water blankets, or cooling caps worn on the head. How many kilojoules are lost when the body temperature of a surgery patient with a blood volume of 5500 ml is cooled from 38.5 degrees centigrade to 33.2 degrees centigrade? Assume that the specific heat of blood is the same as for water. So it's going to be 4.184 joules per gram degree centigrade, and the density of blood is the same as for water, in which case 500 ml will be 5500 ml will be 5500 grams, because the density of water is 1 gram per ml, all right? So so therefore 5500 ml will be 5500 grams as well, okay? So the temperature change, the delta T final minus the initial is 5.3 degrees centigrade. All right. So heat, the formula for heat is mass times the delta T times the specific heat. So 5500 times 5.3 times 4.184 should give you the heat in joules. Okay. So 5500 times the 5.3 times 4.184 will give you joules, but the answer asks you for kilojoules. So 1 kilojoule is 1000 joules. So you'll divide that answer by 1000 and it comes out to be 120 kilojoules with 2 sig figs. Okay. So the next last part of this chapter is changes of state. Okay. So in change of state, you're going from a solid to liquid and to vapor or gas. And if you're going from the solid to liquid, then it's melting. But the reverse direction from liquid to solid is called as freezing. All right. If you're going from liquid to vapor, it's called as vaporization, gas vaporization, and gas to liquid is condensation. Okay. Now there's another phenomena called as sublimation, where the solid bypasses the liquid phase and it goes directly into the gas phase. That's sublimation. And then the vapor condenses to the solid state, not to the liquid state. So it's called as deposition. All right. So when you're going this way, in this kind of circlish way, melting is taking in heat. You have to provide heat to the ice to melt it down. All right. Again, to vaporize water, you have to provide heat. You have to add on the heat. All right. And so again, when you sublimate the ice, like dry ice, to vapor, you have to add heat. But the reverse is you have to remove heat. All right. So if you're taking vapor and condensing it into liquid, then you have to remove heat. If the liquid is being condensed further into ice, again remove heat. Same thing when the vapor becomes solid, then you're removing heat. All right. So the red is heat absorbed, where heat is being taken in, and the blue is heat released, where the heat is coming out. Okay. So melting is changing from a solid to a liquid at the melting point. Freezing is liquid to solid at the freezing point. Now melting and freezing point are exactly the same because it's 0 degrees centigrade for water. Okay. And of course melting and freezing are reversible, and that's why they're physical changes. Heat of fusion is that amount of heat needed when 1 gram of liquid is freezing and becoming ice at its freezing point, or it's the amount of heat needed to melt 1 gram of ice at its melting point. All right. So heat released during the freezing process is the same as the heat needed during melting. Okay. So to melt water, or melt ice rather, it requires 80 cals per gram of ice. All right. So you have to supply the ice with 80 cals per gram to melt it down. To freeze water, you have to remove the 80 cals per gram of water. All right. 80 cals is 334 joules. Okay. So both processes, whether it's the freezing or the melting, require the same calories, but of course in one case it's being added on, in another case it's being removed. All right. So it's 80 cals per gram of water, or 1 gram per 80 cals, 334 joules per 1 gram of water, and 1 gram of water by 334 joules. So when you're doing these heat change problems, again, look at all that is given, what you need, write down your plan to go from point A to point B, write down any conversion factors, then set up the problem. All right, so how many joules are needed to melt 32 grams of ice at 0 degrees centigrade? All right, so 1 gram of ice requires 334 joules. All right, so 32 would be 32 times the 334. Okay, so grams of water cancel, or the ice cancel, water solid cancel, and then 32 times the 334, and you need 3 sig figs, and that's 10,700 joules. Okay, so when water is heated, it eventually starts boiling. When it boils, it's evaporating into water vapor, which collects on the surface on top of the liquid water. All right, and then when it hits a colder surface, heat is exchanged, and then it starts condensing and forming back the liquid. All right, so this is a continuous process between the condensation and the evaporation that occurs at the surface of the water. So when water is boiling, what is happening is the water molecules, the liquid water molecules, are acquiring enough energy, and once they become gas, they leave the surface. All right, and that boiling is when you see those bubbles appearing. All right, that's where the gas, the vapor, is escaping off the surface of the liquid. Okay. Sublimation is when, as I said, the solid directly becomes gas, and deposition is when the gas becomes solid. Okay, so this requires heat being added on, being absorbed, and then the reverse process is that same heat is removed. So this is seen with dry ice. All right, dry ice is sublimating at minus 78 degrees centigrade. So at room temperature, because it is subliming to the gas phase, all right, from the solid to the gas phase, at room temperature it's going to be in the gas phase. Okay. Okay, sublimation is a quick way to remove moisture, much like dehydrating foods, except in this case it kind of preserves the food, because it just removes all the water vapor by solidifying it. All right, so this can preserve the shelf life of the food. Heat of vaporization is the amount of heat required to change 1 gram of liquid into 1 gram of gas at a certain temperature, which is the boiling point. And so for water, that's 100 degrees centigrade. All right. So that amount of heat required to vaporize liquid water to 1 gram of liquid water to 1 gram of water vapor, that is described as the heat of vaporization. And then when you take the gas and condense it to the liquid, it's that same amount, numeric amount of heat that is to be removed. Okay. So that is 540 calories per gram of water, all right, or 2260 joules per gram of water. All right, so water will absorb this amount of heat to become gas, and then water will release this amount of heat when it's in going from gas to liquid. Okay, all right, we'll stop here and continue this in the next video.